Thank you for your cooperation. Number 21. April, what did you choose on number 21? Why is the temperature not changing during the state changes? A, the energy being added is used to separate the molecules and break intermolecular bonds. All right, that's exactly what's happening, and that's exactly why there is no temperature change, because so much energy is going into those chemical bonds. Number 22. Shh. This is from chapter 13. Devin, you ready? The gas constant R has the value of what? 22. Devin, what's the correct answer here?
22.
22. The numbers are all the same. It's the units that we have to pay attention to. A, yes. Why should nobody miss this problem?
Because we're smart.
No, no, no. It's on your purple sheet, your laminated sheet, right? All right. All you have to do is look it up. Right? Now, you do have to know that. You have to have that in your head, okay, that you know that it's on there somewhere. Number 23. Oh, everybody knows this one. Austin Jones, the greater the kinetic energy of particles in the sample of matter, the blank. Don't be looking at your answer key. Okay. A. Shh. Hey, wouldn't it be better to get the answer wrong right now and learn from it like Lamar did? Than to try to be right. I don't care if you get it wrong right now, okay? If you want to talk about Charles' law and we have to talk, correct that answer, then we can, okay, before you make that mistake on a test. Number 24. It's a learning process. Thank you. Shh. Number 24. How much energy does a copper sample absorb as heat if its specific heat is 0.384, its mass is 8, and we're heat? All right, guys, this remind us of the quiz that we took today? All right. Are we going to do this, MC delta T? Are we going to be solving for Q here, people? And what's our delta T in this problem? Is it 30 degrees Celsius? This is your C. This is your M. All right. Any questions there? All right. 25. All right. Answer is on your answer sheet. All right. Oh, shh. Look at this. Interesting. Interesting. Dallas. What answer choices can we eliminate based on the wrong units for 24? We want energy. What is the unit for energy? Joule. Right there. You don't have to do any math or know how to do any of this if you know that joule is the unit we're looking for. Now, if you know that joule is the unit you're looking for, you probably know how to do the problem, don't you, Corbin? Okay? All right. Number 25, activation energy is, remember this. What is this activation energy? Let's go and define this right here. Shh. Where is activation energy, guys? It's the energy between here and here. Austin B. Activation energy. Which letter represents activation energy, actually, on this one? A, B, or C?
I'm going to go with A.
A, very good. Okay, and that's actually question number 31. 31 asked what the, oh my goodness, I'm making a big mistake here. Let's go back here. 25, activation energy is, all right, so now, Austin, help me answer number 25. What would be the right definition for activation energy?
A?
Yes, A. Shh. What would B be? B could be a definition for something else. The net energy required to turn reactants into products. What is that net energy going from reactants to products called? It's that word that some of us don't like to say. Enthalpy. Right there. That is enthalpy, is the net change. Okie doke.
So awkward.
It is awkward. Enthalpy. All right. Right. You sound cool just by saying it because it sounds like a challenging, you know, high class word. Yeah. Yes. Right. All right. Number 26, in an energy profile graph, the activated complex is represented at the, Michael Albert, where is the activated complex? Here. Is it at the left side, the right side, or the top?
Now, if you look at the answer, if you do it. Do it, Mike.
What? Did you say the top side? Yes. All right. The top of the curve, D, is the activated complex. This, remember, is a temporary structure. It's an arrangement of molecules, isn't it, Megan? Okay? Dallas, pay attention. Shh. Which is true in an exothermic reaction? Over here. Chantel. Shh. Is this endo or exothermic?
Endo.
Exo. The ball has rolled down the hill. We have a negative delta H.
Oh, I see it now.
Right? All right. Shh, 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 shh. Now, who has the highest amount of energy? Reactants, activation energy, or products? Who has the most energy? Activation complex, right? Who has the next amount of energy? Reactants. And then products. So how can we say that here? How can we say that here? Is letter A, where do we want to see activated complex? At the top, right? Does everyone understand why I'm eliminating those two? Because I want activation energy to be at the top. Yes? All right. Eric, what's the next thing lower than activated complex? The reactants, right?
Yes.
So which one of these two answer choices is going to be right? C is correct, okay? Because we have activation energy the highest, then reactants, then products. Zach, can you shut the door? All right, good one, Eric. Not falling for that nonsense. Yeah, I know, right? Okay. Shh. Now, let me tell you this, Zach and Brandon, y'all need to pay attention to this for next year. Shh. When you have a spontaneous reaction, you always have a negative delta G. Say, what is delta G, Miss Milam?
What is delta G, Miss Milam?
Say, that must be another enthalpy, entropy, tricky word to say. It seems like it, but guess what it's called? It's called Gibbs free energy. Does anyone have any trouble saying Gibbs free energy? You have any trouble saying Gibbs free energy? Say no, I don't mind saying that.
No, I don't mind.
All right, makes me sound cool. All right, shh. Gibbs is a famous scientist. All right, shh. When is the reaction spontaneous? Remember what, hey guys, pay attention. This is kind of new information here. Dallas, eyes up here on your paper. 28. When is, what does nature tend to want? Endo or exo? Endo or exo? Exo. Shh. So a spontaneous reaction will happen when we have an exothermic reaction. Now, when else are we going to have a spontaneous reaction? When entropy increases or decreases? Very good, Chantel. Increases. So the correct answer here is B. How do you like that? Yep. Say, I can't believe we're almost done, Miss Milam.
Can't believe we're almost done, Miss Milam.
All right. Next.
I can't believe it's not a buddy.
29. Which would increase the entropy of a system? Positive. Is this what nature wants? Yes or no? Yes. All right. Shh. We're going toward more disorder. Devin, is this getting more or less disorderly? Gas condensing to liquid. Less random. Where this is a negative, this is a decrease in entropy. It's very hard to get this right. I have trouble with this. Shh. We have a decrease in entropy because we're becoming less disorderly. What does less disorderly mean? It means more orderly.
Yes.
Gas to liquid means we're getting more ordered. I know you did. I know you did. So this won't answer the question. Here we go. We're going from a solid and a gas to one single solid. Is that an increase or decrease in randomness? Decrease. That's a negative, delta S. C. Shh. Ice forming on your window from water vapor. That means gas going to, not liquid, but solid. Increase or decrease? Positive or negative?
Increase. Decrease.
Decrease. Okay? How about this? One compound, solid, going to 5 moles of a substance, solid, solid, and a gas. Is this an increase or a decrease in entropy? It's an increase. We're getting more disordered, okay? That's the right answer. Now let's just check these other things. Shh. Why is cooling something going to be a decrease? Why is cooling something? Brandon, what happens to the particles when they cool off? How do they behave differently when they get colder? They slow down. They just move slower and they're less disorderly. All right, and then finally we have 2 elements becoming one compound, 2 moles of something becoming 1, so that's, again, a decrease in entropy. Number 30. Number 30, Maggie, the process by which engine fuels burn is called what? This is actually from physical science, but I put this on here because this is a basic chemical process that we've learned that we need to know. A, combustion. Very good. All right. Maggie, she's Maggie-tron. She's got a future in the auto business. All right, with that combustion engine. All right. Shh. Hush. 31. Hush. Be quiet. In this reaction, the enthalpy for the reaction is what is the enthalpy represented by, Kat? Enthalpy, A, B, or C? Very good. It's this one right here, C. Okay? Beautiful. And then number 32, letter A represents, Jasmine, what does letter A represent? Enthalpy change, entropy change, energy of reaction, or activation energy?
Wait a minute.
That's just one of the E words.
It's not E. Correct.
Correct.
And
It's not E. There is no E.
She's correct.
I meant D. I can't see that bar. Okay. A.
A. No.
I'm just kidding. I meant to say B.
Letter A is going from reactants up to this activation complex.
I said D.
Yes, you did say D. Very good. It's the activation energy, isn't it, Jocelyn Smith?